So here, I've written some basic rules for derivatives, and the first one says if f of x is equal to c, where c is like a constant like 5 or 10, then f prime of x, and f prime of x just means the derivative of f of x is going to be equal to 0. And this makes sense because if the function is a constant, then that just means it'll just be a straight horizontal line like this, and the slope at any point in this graph is going to be equal to 0. And next, this one is if f of x is equal to x to the power of n, then f prime of x will be n times x to the power of n minus 1. And this one is usually referred to as the power rule. And for example, if you have x to the power of 5, then this will turn into 5 times x to the power of 4 as this derivative. And the next one is if f of x is equal to a constant multiplied by another function of x, then the f prime of x will equal to the constant multiplied by the derivative of that. So for example, if you have like 5 times 2x, well, if ignoring like the fact that you can expand this and just do it, if you take this constant out and just focus on the derivative of what's inside these parentheses, 2x, the derivative of that is 2. So you have 5 times 2, which is equal to 10, and that's the derivative. And for this last one, it's if f of x is equal to u of x plus v of x, where both of those are functions of x, then f prime of x will be equal to u prime of x plus v prime of x. And for example, if you have x squared plus 5x, then this is just equal to, you can like isolate these each by itself. First find the derivative of this, then find the derivative of this, and like the rule said, add them up, so you get 2x plus 5 as your final answer. Now, let's do some examples. So this first one says f of x is equal to 4. And we know that if f of x is a constant, then the derivative of that will just be 0. And here it is a constant because 4 is a constant. So f prime of x is equal to 0. And for the second one, it says f of x is equal to x to the power of 7. And for the power rule, we can just implement that here. So f prime of x is equal to 7 because we bring this power to the front times x to the power of 7 minus 1 is equal to 7x to the power of 6. And that's our final answer. For this third one, we have f of x is equal to 4 times x squared. And we know that we can kind of ignore this constant for now and focus on the function that's being done on x, which is x squared. So we have f prime of x is equal to 2x because that's the derivative of x squared, but we need to bring this constant back into here, and we multiply the whole thing by 4. And we get 8x as our final answer. And for this last one, we have f of x is equal to 5x plus 2, and we can just find the derivatives of each thing individually. So 5x and 2, and we add them together. So f prime of x is equal to the derivative of 5x, which is 5, and the derivative of 2. And we learned before, the derivative of a constant is always 0. So 5 plus 0 equals 5. Now, let's do some practice problems. If you think you know how to do this one, then pause the video and try it. This one says, find dy over dx if y equals 4 times the square root of x plus x. Now for this one, we can use the rule we learned where we can isolate each term and find the derivative of each individually, then add them all up. So first, let's find the derivative of 4 times the square root of x. Well, we can see that 4 is being multiplied by a function of x, so we can ignore the 4, which is a constant, and focus on the square root of x for now. Square root of x can be rewritten as x to the power of 1 over 2, and using the product rule, we can determine that derivative of this is equal to 1 over 2 times the square root of x. But remember, we must multiply by 4, so we get 4 over 2 times the square root of x, and these cancel out, and this just becomes 2 over the square root of x. And now, let's find the derivative of x. That's just 1 because the slope is 1. And our final answer is 2 over the square root of x plus 1. Now, let's do another practice problem. If you think you know how to do this one, pause the video and try it. This one says, find dy over dx if y equals 1 over 5x squared. And for this one, I can notice that we can rewrite this as 5x squared all to the power of -1 because this is a fraction where everything is on the denominator. And this is equivalent to 1 over 5 times x to the power of -2. We just distribute the -1 into each term. And 1 over 5 is a constant, so we can ignore that for now. So let's just find the derivative of x equals -2. And using the power rule, I can determine that this is equivalent to -2 times x to the power of -2 minus 1, which is equal to -2 times x to the power of -3. And x to the power of -3 is just 1 over x cubed, so it's just -2 over x cubed. So this will be 1 over 5 times -2 over x cubed, which is just -2 over 5 times x cubed. And that's your final answer. Now, let's do one last practice problem. If you think you know how to do this one, then pause the video and do it. This one says, find dy over dx if y equals 6x squared minus 9x to the power of 4 all over 3x. And this one might seem a little weird too, but what I noticed is that you can factor out a 3x from all terms inside this fraction. So let's rewrite this as 2x minus 3x cubed. And we can also use the rule where we find the derivative of each term individually. And even though it's not a plus sign in the middle, if you think about it, it's just equivalent to 2x plus -3x cubed. So it's the same principles. So let's find the derivative of each of these individually and subtract them. So 2x is just 2, and 3x cubed is just 3 times x cubed, the derivative of x cubed, so it's just 3 times 3x to the power of 3 minus 1, which is just 9 times x squared. So it's just 2 minus 9x squared, which is your final answer. So everything that I explained in this video and all the problems that I went through should teach you everything that you need to know about the basic rules of derivatives. If you learned something from this video or if you enjoyed it, then please consider liking and subscribing.